Hey, welcome back. So in this video, we're going to go through solving this system of three equations with three unknowns. Let's get into that. So the first thing that we need to do, equation number 2, equation number 3. So out of the three equations with the three unknowns, we are going to make a system of two equations with two unknowns and then solve. So the first step, you're going to add equation 1 plus equation 2. Now, you would ask, why is it that we need to do that? Well, I want you to pay attention to this plus y term and minus y term. In order for us to focus only on two equations at a time, is that we need to be able to manipulate the two equations and get rid of one of the variables, so we make it two equations with two unknowns, and therefore we can create a system. And that's what we're doing. We're pairing up two equations at a time. So once we do that, when we add the first equation plus second equation, what you will get, so these are the two equations we are dealing with. We're adding the two equations. So what do we get? We get 3x, because x plus 2x is 3x, plus y minus y, that actually is 0, and then plus 1z plus 3z, that is 4z. And that's equal to 3 plus 1 is 4. Let's call this equation A. Okay, we have two unknowns, x and z. Now, once we have these first two unknowns, our next pair that we are going to use, we have to manipulate the equation in such a way that we only get x and z. So now we're going to pair up equations 2 and 3. So now we have equation 2 and equation 3. Now with the equation 2 and 3, I'm going to bring it down here. We have to manipulate that first. So let me write this first. So this is equation 2 and 3, right? And look at, I have boxed the minus y here and plus 2y. We need to get rid of the y values or y variable from both equations so that we have a system of two equations, that one in each of the equation has got an x and z. So we need to eliminate the y. In order to do that, we have to do elimination. So we're going to multiply equations by -2, actually in this case just 2, +2, that will do it. So let's do that. Let's multiply. We're going to multiply the entire thing, so both sides of the equations by 2, and we are doing multiplication only to one of the equations, that equation number 2, because equation number 3 we leave it alone because we already have 2y in here. Now by multiplying the top equation by 2, we really we're not doing anything illegal mathematically. Whatever we're doing to one side, we have to do it to the other side. So really the value of this equation has not changed. So when you do this, this is what you will get. Here is the new equation being multiplied by 2 right across the board, and we have multiplied 2 in each term, every single one right across. We rewrote the equation 3 as is. We haven't changed it. We have modified equation 2 and 3. I'm going to put the star above equation number 2. And now what we are going to do, add, so equation 2 star plus equation 3. Okay, so this is what now we're going to do. So this is what the new equations will be. And to do that, we're just simply adding, and when we add, we get 4x minus 3x, that's just single x, minus 2y plus 2y, that's 0. Here we got 6x plus minus 4z is plus 2z, and here we have 2 plus 8 is 10. Let's call that equation B. So now we have equation A, we have equation B. Look at the first equation is this one, and the second equation is that. Here we go, the two yellow equations, they're both in terms of x and z, and we're going to rewrite these. And now we have a new system of equations, two equations, two unknown, and now we're going to solve. And we're going to do the same thing, process of elimination. Whichever variable you decide to get rid of, that's okay. Doesn't really matter. We can do the z this time if you want to. So if that's the case, let's multiply both sides of the equations, the b equations, by 2 so that we have the same a value of 4, and then we can subtract the two equations. So here it is, we multiply the equation b by 2, because 2 times 2, that gives us 4z, and a 4z minus 4z, this 4z minus 4z, because subtract b from a, and then you will get a new equation. So the new equation that we have will give us 2x plus 4z is equal to 20. Rewrite, and now we're going to solve for the last. So what do we do? So in this case, we are just adding or subtracting. So this is subtraction. Do the a minus b. What do we get? We get 3x minus 2x, that's 1x. 4z minus 4z, that's 0. 4 minus 20, that's negative 16. That's our first value, x. Okay, now once we get the x, we go back and we can substitute x into equation b. So here it is, sub into equation b, and we are going to sub into the original equation b, as in the original manipulated b, right, not the top equation. And then what we'll get is negative 16 plus 2z equals to 10. We're solving for z, so 2z equals to 26, z is equal to 13. I have jumped through a couple of steps, and I assume that you guys know how to do that. So we have x and z, then now we can go back to any of the three equations from the question. So the easiest one is this one, the first equation, equation 1x plus y plus z is equal to 3. So is that plus or negative? That's plus. Z is equal to 3. X plus y plus z is equal to 3. Okay, and that's what we will get. We will get negative 16 plus y plus 13 is equal to 3. So in this case, we have negative 3 plus y is equal to 3. So y must equal to 6. We're adding 3 to both sides. Therefore, now we have all the three values. X is negative 16, z is 13, and y is equal to 6. These values should work and must work for every single original three-variable equation. When you plug it into equation number 2, it should work. If you plug into number 3, it also should work. Now let's check quickly equation number 2. 2x minus y plus 3z equals to 1. So in this case, we just checked. Look what has happened. Perfect. We put it back in there. We got 1 is equal to 1. The equation holds. And I'm going to leave the last check for you guys yourself. Do the check for the third equation. And this is the solution to this system of three equations with three unknowns. I hope this was useful. And if it was, please subscribe, or doesn't matter, just come back to the channel. It's all good. Thank you, and see you next time.